Hi, so before I waste your time, don't click off, just listen. So the agenda of this video to begin with, so you can flick through, get everything you want to get out of this video without listening to me waffle on for 25 minutes. So at the beginning of this, we're going to be talking about offset, all the offset details, and then we're going to be talking about plane setting, and then we're going to be talking about the tooling info regarding how you set up your tool into your planes, and everything else regarding that. And then the rest of the video is going to be about manipulating your post, setting your post up, how you write macros, what all the macros mean, where the data comes from, etc, etc, etc. I'll put all the times for everything on this short video now, because obviously they've all changed since I've added this 50-second clip in. Okay, cheers, enjoy the video. Hi, welcome to Mill Savvy Tutorials. I'm Luke, and this is the channel where I try and do everything in one take, so I don't have to spend too much time editing the videos. I'm not a YouTuber by any standard, as you can see from the editing in these videos. I'm an engineer, so this is all new to me. I'm figuring it out as I go, really. But what I'm trying to do is try and give some good advice on, you know, how to use OneCNC to get it to do whatever you want it to do. If you're struggling with certain things, then let me know, and I'll create a video on how you can either do things the way I do them, or teach you the ways you can manipulate them to suit your needs. Don't try and claim to know everything there is about OneCNC. I've just used it for a long time, and I like it. I think it's a good bit of software. I mean, for 5-axis and stuff, don't get me wrong, there's better bits of software out there, like your Fusion and your Hypermill, your Mastercams. There's loads, but if you purchase this and you've got 5-axis machines, and you don't want to pay for another seat on another CAD package, then you can use it for doing some 5-axis machines. I wouldn't ever do sort of full 5-axis style with it. I think OneCNC tip of the day will show you some full 5-axis toolpaths. I'm not going to go showing you that, because that's not what I've used, and I didn't really get on with the 5-axis side of things on OneCNC, just being honest. 3-axis, brilliant. I'd say it's one of the best 3-axis softwares you'll get, just because of the logic and the toolpaths that are into this software. I think they're very, very powerful. Underrated, in all fairness. You know, people go, Fusion, Mastercam, Hypermill, whatever, especially Hypermill. I hear that all the time. And they are fantastic, don't get me wrong. I've used Fusion and Hypermill, but I've also used this, and this is the one I'm super confident on. I like this, I keep going back to it. I just like the toolpath. So without spending too much time waffling on, right, let's just show you what I'm going on about. So this is your sort of your 2-axis hash trunnion that some of you might be familiar about. You can buy these for about 30 grand, I think, brand new, I think. Don't quote me for it, it's not like I've purchased it. But this bolts directly onto the bed of a VF2, as you can see. You could bolt these onto whatever you want, as long as they've got 4th and 5-axis capability around the back. So to talk on this a little bit more, so I'll just get rid of that photo and I'll show you the offset page. So what the offset page looks like when I'm going to show you how to set this up on OneCNC. The center of this trunnion, so this sort of orangey point here, will be the center of well, it's not technically the center of rotation, but that's the center of the platter. This is your platter here. These are where your lang vices and stuff bolt. I just need to add this in. I'm going to pause the video and add this bit in, but I forgot to mention in this video, so I'm going to mention it now. All the tools on this machine are set at 125mm above the center of rotation. That's where that Z figure comes from, okay? All the tools are set off a post that you can't see in this video, or this photo, to the left hand side of that trunnion, which is exactly, well, it's actually 115mm, but then there's a 10mm like setting block that gets used, so it's 125mm from the center of rotation. So that Z-axis shift is to bring all of them tools to be basically set from the same 0 point of rotation, if that makes sense. If it doesn't, leave me a comment, I'll try and explain that a bit better, but that's my best effort basically. Roger, or whatever work holding you're using will bolt to here. And then if you look over here, if you imagine there's a little center point there, and this rotates around that point runs through here, and you'd think it would be flush with this face here, or even flush with this face where this platter bolts to. It isn't quite. It's actually like, I think I can't quite remember, it's been a long time since I've actually clocked one of these in. I think it's about 5mm higher than that face there. It's irrelevant. You just need to find the center of your rotation basically, and that is where like you'll set all your tools from basically. That's where your datums come from. So on this particular machine, we set our tools 125mm higher than our center of rotation, hence why we have this figure in here. And don't worry, it's not like your Z0s are going to be down here, and if you make a mistake you're going to plunge into it. I'll show you what you do. You use macros to offset this datum to give you these datums down here. Right, so you've got your G154, P1, 2, 3, 4, 5, right up to whatever your machine's capable of putting out. I think some of the classic controls go up to 200, I think, and the latest gen has controls. I think they go up to like thousands or something like that. Don't quote me on it. It's not like I'm going to study the offset page. I just know how to get by with it. So anyway, so let's jump into this. When you've got your model like this, when I first set it up, I'm going to orientate it as if like I'm looking at it from the spindle's point of view. So you can imagine this part here is in a vise. I've just shut that image down. Let me just reopen that image of the trunnion. Hold on, come on, open up. Right, my part's in a vise here. Part's sitting about here, and I'm looking from the spindle down on top of it, and that's the view I'm going to see from the spindle. So that would be what I call P1. And now if I want to rotate it, which I'll show you how to do it with the macros when I post this program, I would call that face P2 because it's at the back, and then I'd directly opposite, I'd call that P3. I'd call the face to the left of my P1, P4, and the opposite one I'd call P5. You call them whatever you bloody want, it doesn't matter. But you just need to know how you work and work the same every time. So to set these planes up, you can see here I've labelled them like this, and you can see the plane changing, look. And it's very important that you have these highlighted when you're applying your toolpath. So there's my P1, there's my P2. So all I would do to set this P2 up is that I'll just redo it to show you. Before I jump in, I create points at where I want to datum that plane from my P1 face, top face. Yep. Once you've got your point where you want it, it's very easy to do that, because what I do is I extract the profile lines and then put a point in the center of it. So it's quite simple. Don't try and do anything complicated, there's no point. Create a plane from the surface, select that, move your plane to a point, select that point. You can see this, how my plane is not orientated how I want it. A lot of the time, all you've got to do in this situation is rotate it around the Z-axis tilt by 180. And you can see there, that's set up how I want it to be set up. See, now before I do anything else, you want to click save. I've already created a plane, P2 plane, so I'm not going to click save. But if you're doing this, save it, name it what you want. If you click save, look, it comes up and gives you a choice. Name it P2 plane, G154 P2, whatever, up to you. Call it Steve if you want. Anyway, you can see there, look, my x-axis goes sort of to the right, y-axis is going towards the back, and the z-axis is going up. That's how you want it to be set up. That's how your P1 and everything else is going to be set up. So you want all these planes to be set up with the right orientation. So now you know how to set up your planes, and obviously you know how to apply a toolpath to a part. As you're working your way around it, so watch this, for instance. I'll flick through it so I can show you what I mean. Let's just grab my P1 plane. For instance, that's P1, 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 and as it's going on, look, I'm doing everything I can, and then look, you can see that it jumps to P2, but you can also see, look, this plane moves. Right, that's because when I'm applying this toolpath, I'm making sure that I've got this selected. So every time I apply toolpath, I select that plane. It's a little bit more work compared to what you'd have on something like Fusion, but remember, I'm using 3-axis reposition. This isn't full 5-axis like software at this point, if you know what I mean. So if I just go edit to show you how I'm doing it, that's how I would program with my work offset, right? So if I'm using P2, I'm going to program it with P2. So this is very easy to get this wrong, because this will default to whatever you're using on whatever toolpath you're selecting. So if I'm using profile, it might be, the last time I used profile, it might have G54 in there. I don't want it to be G54, I want it to be my 5-axis macro datum, which is G154P2. So I need to remember to add that in. So you can get this very wrong, so you need to be careful, right? I'm not going to try and say this is it, I'm showing you how you can manipulate it to do 5-axis on a 3-axis reposition option here. So don't get me wrong, there might be better ways of doing it, but this is how I figured out how to get it to work for me. So what I do once I've done all this, I'm not going to post it anytime soon. I'm going to do a lot of like manual checking here. So as I'm going down my toolpath, I click on these and I check here, look, don't want to alter it, I check here, I'm like, yeah, that's P1, that's a P1, P1, and I work my way all the way down this list, checking everything I've clicked and typed is correct. The last thing I want to do is post a 5-axis program out wrong. It rotates to the wrong face with the wrong macro settings, and I put a tool through the job, or the vice, or smash the machine, or damage something. That's the last thing you want to go doing. So I'll show you what the post looks like. This is my sample. Look, has 5-axis post. If I click, I haven't quite perfected this post for this video. I need to go do it, but it's close enough for me to show you an example. Just quickly save over this. You can obviously see that I did a video and then thought, nah, that's a bit rubbish, I'll redo this quickly. I think I can do it in less than 15 minutes. So so I don't want to focus too much on what's going on at the top here. I'll be repeating myself from the previous videos. The only thing I will mention is, look, it says warning, duplicate tool stations, duplicate station used, yeah? And all that is where I've used the same tool to chamfer and spot. That's all it is. And I've just had them set up as two different things in my library, because this one, I've cheated it to think it's a 3mm tool, look, 1.5mm offset. I'll literally, before I post it, I'll just delete it. Right, so this is the bit that will take a bit of time to explain. This is your macro. This takes all its information from, let me show you. Hold on, not that, not that. Let me pull up the image. It takes all its information from these lines here, G54, X, Y, and Z, A, and B. Okay, so let me pull up the picture of the trunnion again. The A-axis in this trunnion will be this edge here rotating, like, it's hard to show you with a mouse, but it will swing like this, yeah? And the B-axis is this platter here, and it rotates either clockwise or counterclockwise, right? So a B-axis is a rotation around this center point here, and an A-axis is a rotation around this center point here of the trunnion. Some are different, they're B, C, AC, whatever, yeah, doesn't matter. For this example, I'll show you what we're using here. So my P1, for instance, let me pull that back up, will be 150mm higher than this point here. So don't try and worry too much about what this number is. It's kind of irrelevant once it's set, because you just set everything from the center of rotation, and that's all you really need to know. All I need to do is, if I pull up that picture one more time, I should have explained it just then. My job, say this here is 25mm above center of rotation, because center of rotation is down here somewhere. Say that face is 25mm plus, right? Then I've got my vice, then I've got my job, right? And then I need to allow for a skim, so I'll come down a little bit to allow like a 1mm skim on that billet. See, that distance from there with the skim down to the center of rotation is, just for this example, say it's 130mm. All I've got to do, I'd work it out obviously, go space, plus, space, 130, dot, space. Yes, you do need these spaces, right? It's a bit silly, but you do. So that would be my Z set. If I don't put anything in the X and Y, they default to the center of rotation, which most of the time will be perfect, because everything you program a lot of the time comes from center. If you want to offset it, if you want to program something from the corner, say your job's 50mm square, and you wanted to do it from the left hand corner, you go minus 25, like that, and you could go there if you want to go from the back of it, plus 25. It's that simple, and then you program from that point. But if you program from that point, remember on your OneCNC, let me just shut that. That would be, so for instance, if I was on P1, and just humour this is say 50mm by 50mm now, that would be this corner here, because you remember you're going minus, plus, that's there. You can see, look, your X and Y are orientated like that, that'd be that corner. So let's bring that back up. You can see how I've set my plane up, it's centre, so I need to leave that as its default positions. So to explain this as quick as I can, X, see it's hashtag 5221, that refers, pull up my date, this again, let me minimise it so you can see a little bit more. That refers to this line here. So that's basically saying, whatever the figure in there is, take that and put that there. Right? Obviously this is not a photo of this macro, so these numbers are not going to match up, just to point that out. But if I run that macro, that number would be the same as that number. Why? Hashtag 5222 is this line here, so it's saying take that number and put that there. If I had a plus 25 in there, it would say, this is how the machine would understand it, take that number and plus 25 to it and put it in there. It's honestly that simple. The Z, take that number, put it in there and plus 130mm to it. So that'd be plus 5. Alright, A axis, 0. Put 0 there, put it there. B axis, 0. Alright, take that, put that there. You know, if these haven't got anything in them, it will just take whatever's in this box and put it down there. As you can see, whatever macro I did read had the same idea. Yeah, and then you set these as your datums. This line here is basically just, it's a macro line, but this is a G10. This is a glorified G10. So, you know, you've got your G10 saying basically take from somewhere or apply an offset somewhere, and then an absolute command, which you could probably delete to be honest. And then your L20 and your P1 refers to a G54. And then these are where you're pulling your data from. So to set up your P2 and 3, so yeah, I have killed 5 minutes already, I just had a look at the stream. All I would do is I'd copy this. I wouldn't do that, hold on. And I'd paste it, and then I'd alter it for my P2. So I'd over there, I'd go P2, and I'd say back face, and I'd call that P2, and then they're the same, other than this now turns into minus 130 because your Z becomes your Y when you rotate it at 90 degree. I click plus 90, B's not changed, right? And then that's how I want it to be. That, remember, if it was 50mm square, that would be plus 25. Alright, because you're coming from the centre of rotation. So now if your trunnion rotates 90 degrees down, you're coming up from the centre of the trunnion, which if the part's only 50mm square, then it's only going to be 25mm. I can't show you a picture of that because I don't have one. But that obviously would be down here somewhere, and obviously it would be in line with the centre, and then plus your 25mm up, and that's your top of your job. P3, let me just space that out, put that back. Because P3 is similar to P2, and the only difference is the fact that my B axis has rotated, I'll go P3, I'll just call that front face, call that P3, yep, that's alright, because it's, remember if you're not coming from your datum point, then these things might be different. But I'm coming from centre, so this is how this works here. And then all I've got to do here is go plus 180. Just so that would be my macros basically set. If what I told you was true, for instance, the job is 50mm square, it's 130 from centre of rotation to the top to allow for a little skim. So they're your macros. This is how I've cheated my post. So I've gone like this, I've gone like G154, I've typed these bits in manually in my post. And and I'll flick to that in a second, and I'll put the A and B in there as well, and then obviously you've got these Zs and everything else coming down, and then you've got your safety lines here to lift up to tool changing height before it goes moving away. And then all this is this basically programs the machine to, hold on, let's get down, hold on, wrong photo. When it tool changes, this whole lot will move into this corner over here, and then obviously the tool changer is up here, so it just gives it a bit more clearance. When it's tool changing, you can set a safe tool position about 2 or 3 different ways on a Haas machine. The way this machine was set up is we programmed it with a -762 because that's the max X position, but also when it read an M6 code, it knew to move to that position. I think I've got a note in one of my engineering Bibles basically how to do it. I can't remember how you do it off the top of your head. I ain't done it for years, but I could do it if I had to. So there's not much you change from a standard Haas post to get it to work with 5-axis. So let's shut that down. I'll save it. I'm not going to post this and machine this part. It's just obviously for a sort of example. So tool format. You can see here how I've changed it slightly from a standard. Obviously I've added like a holder and exposed length, because on 5-axis that's very, very critical information. For instance, I might be using a shunt hydraulic holder or like a Hamer heat shrink, or whatever it is. You need to tell the guy you're posting this out what you're using, and what you're sticking out. For instance, you're sticking out 30, then put 30 in there. The guy don't know. Right, OneCNC posts. Let's show you what I mean. Job sheet, and it tells you what tools you're getting and everything else. Let's see what I get here. Look, bear with me. You get this information, but they don't tell you stick out, and it doesn't tell you what holder you're using. This is, quite basic, isn't it? As you flick down here, it gives you a bit more information. But anyway, you need to tell people what you're doing. You're running the graphics, you're seeing everything, you've got all the information here. You need to type that in a program and give it to the guys and girls on the shop floor, so they know exactly what's safe, and then that way you've got the best chance of getting it right first time. The only things I think have changed, obviously my A and a B, my work offset that's still standard, because obviously I actually type it in how I want it to be. Next tools there, G4P2, obviously I've added that, and then we start finishing. I've added this, I've added a macro there for me to fill out manually. Unfortunately, OneCNC will not populate this for you. Don't get me wrong, if a OneCNC expert, watches this, they might know a way of getting this to populate for you, or they might say you've got no chance when you use 3-axis reposition. You need to be using the 5-axis. Stock tool paths and 5-axis up here. But me personally, I didn't want to pay for this. This can do what I want, and even when I did use this, I didn't see many benefits to it. But then I didn't pay for many tool paths either. So it's up to you at the end of the day. If you've got full access to it and you want to go down the path of figuring it out, then fair play to you, but I couldn't find much out. I couldn't find much on the internet around these 5-axis paths. Nothing that made me want to use it. I really like the 3-axis side of OneCNC. I think it's super powerful, very easy, quite user friendly. There's a lot of ways you can manipulate it to do things that other CAD softwares can't. So I'm a bit of a fanboy when it comes to that sort of thing, but that's why I bought it. Don't think there's much else to say about 5-axis. Don't get me wrong, parts vary massively. I can't show you too many. Obviously, there's a lot of NDAs and stuff like that. This is something I've designed. I can show you this, but obviously my customer parts I can't show you. I'd have to redraw a version of it or something like that, and I could show you in a video like that. But if there's anything you guys can think of that you want to see, just send me a message. Subscribe if you can. That'd help me out. The small amount of viewers I do get, if you could subscribe, I'd appreciate it. But if not, I don't. Whatever, it is what it is. All right. Thanks for watching. Cheers, guys. Bye.